Hello guys, and today's topic is changes of state, an introduction to different phase changes of matter and their examples. Recall states of matter. In the previous lecture, we studied about solid, liquid and gases and its particle arrangement. Solid have fixed particles arrangement, then liquid, the particles in here can roll upon easily, slide upon one another. Gases have a lot of free spaces between particles of one another. Is it possible for a solid to turn into liquid or gas? How does it occur? In today's lecture, we'll come to know. Learning outcomes. Explain how a change of state occurs. Compare and contrast the four common changes of the state. Cite a few applications of change of state. In today's lecture, we will only study about the four state common changes. In the next one, we'll go for further. Keywords for today's lecture: melting point, the temperature at which solid melts to liquid. Boiling point, the temperature at which liquid changes to gas state. Freezing point, the temperature at which liquid changes to solid. And condensation point, the temperature at which gas cools and forms into liquid state. Change of state. Now what is change of state? Change of state occurs when matter changes from one state to another. It is reversible process. That is, if a solid changes to liquid, you can change it back to solid. So it is reversible. It occurs when heat is removed or added. We either supply heat or remove heat. Alright. Then it is a physical change. There is nothing chemically involved in it. It's just the change of the state. That's it. The formulation and everything will remain the same. Types of changes of state. First one is melting. In melting, solid changes into liquid. For example, a block of butter melting. Butter was in a solidified form in solid. Then at room temperature, it starts to melt and become liquid. Particles in a solid state are in a fixed position and can only vibrate. When a substance in the solid state gains energy, okay, usually by heating, the particles are able to move more. They are able to overcome the forces of attraction, holding them in a fixed position, and can move past each other. In here you can see when we applied heat to a solid, this is solid arrangement, right? Solid state arrangement. It starts to melt and it converts into liquid, and in liquid there are some spaces between the particles. After melting, the substance will be in the liquid state. The individual particle remain in the same size and shape. For instance, if I talk about this particle after melting will be having the same shape and same size after melting. So the particle size and shape does not matter. Only the state has been changed. Melting point. The temperature at which a substance changes from the solid state to the liquid state is called melting point. Mind it, melting is the change of state, and melting point is the temperature at which the change will occur. Different substances have different melting points. For example, melting point of gold is 1064 degrees Celsius and for gallium is 30 degrees Celsius. Now just see that gallium at room temperature, gallium will melt, whereas gold will take a lot of heat to melt. From this, we can come to know that forces of attraction in gold is very strong. They're the strongest, you can say. That is why it is taking so much time to melt. Gallium. Gallium, a metal that melts in your hand. Gallium is a soft, silvery white metal. It is solid at room temperature but can turn into liquid in your hand. This is because of its low melting point at 29.8, which you roughly said 30 degrees Celsius or 85.6 degree Fahrenheit. So it is a question time for you. When a substance melts, it changes from solid state to liquid state to solid state to gas state, or liquid state to solid state. Think of an answer, pause the video and then check your answer. If you answered solid state to liquid state, you are correct. And also if you are wise enough to see a picture in front of you, you'll be able to guess it very quickly. Second type is freezing. In here, the liquid changes into solid. In here, the heat is removed. During melting, we added heat. During freezing, heat is removed. And what happens is liquid changes into a solid. For example, water turning into ice. When a substance in the liquid state loses energy, usually by cooling, the particles move less. They are not able to overcome the forces of attraction holding them and can vibrate in fixed position. When they start to vibrate in a fixed position, that means it has already become a solid. In here you can see solid. This arrangement is for solid and this arrangement is for liquid. After freezing, the substance will be in the solid state. The individual particle remain the same size and shape. Freezing point. The temperature at which a substance changes from the liquid state to solid state is called the freezing point. Make sure that you do not confuse between freezing and freezing point. Freezing is change of state, whereas freezing point is the temperature. Freezing point is the temperature at which this change will occur. Now remember this thing that melting point and freezing point, same temperature for a substance. They are the same. There should be a comma in this. For example, melting point of ice is 0 degrees Celsius. Similarly, freezing point of water is 0 degrees Celsius. Ice is nothing but water, just in solid state. So you'll commonly hear the word melting point rather than the freezing point. Again, a question time for you. Which of the statement or statements are true for the change of state freezing? Particles lose energy. Particles gain energy. Liquid state changes to solid state. Solid state changes to liquid state. Pause the video, think of the answer, and then check whether you were right or wrong. If you answered particle lose energy and liquid state changes to solid state, you are correct. If you are getting confused, then make sure that you have at least one example settled in your mind so that you can be clear of the answers. For example, for freezing, first thing that should come to your mind is any example, suppose ice. So when you freeze water, it becomes ice. So water is liquid and ice is solid. So liquid becoming to solid. So just if you're not able to remember it this way, try remembering it via example. So a quick recap of what we studied till now. First, we studied melting, where solid changed to liquid when heat was added. Whereas for freezing, liquid changed to solid when heat was removed. It means that these are reversible process. When solid was given heat, melting happened and it converted to liquid. When the same liquid was frozen or we gave a freezing point to it, it converted to solid. So it is reversible process, and mind it, for reversible we use this arrow. The third type of change of state is boiling. In here, liquid changes into gas when heat is added. For example, boiling water. You can see the bubbles and they are forming steam. When a substance in the liquid state gains energy, usually by heating, the particles are able to move more, are able to overcome the forces of attraction holding them in a fixed position, and can move quickly. In here you can see liquid state on heating. When we add heat, it starts to boil and form gaseous state. After boiling, the substance will be in the gaseous state. The individual particles remain the same size and shape. In gaseous state, there are a lot of space. There is a lot of space between the particles, whereas in liquid, very less space is there. Boiling point, the temperature at which a substance changes from liquid state to the gaseous state is called the boiling point. Mind it, boiling and boiling point, they both are different things. Boiling is change of state, whereas boiling point is the temperature at which this state of change will occur. On boiling a liquid, bubbles are formed and these bubbles are released into the surrounding air. For example, boiling point of water is 100 degrees Celsius and vegetable oil is 200 degrees Celsius. You might have seen many times that while you're boiling water in kettle, there are bubbles formation, and that bubble formation leads to steam, and then that steam disappears after a certain point. What happens is that this steam gets into surrounding, and then it is basically in the surrounding. So bubbles lead to the formation of this steam. So whenever you see there are bubbles when you are heating anything, it means that it is boiling. It has reached its boiling point. Also, one more thing to remember is that when something boils, it starts to expand and therefore takes larger volume. That is why you can see that in liquids, if the particles are this much close, Then in gaseous, they are these like farther away. So because it expands and spreads to a larger volume. There's a question time for you. Which of the following statement is true for boiling point? The temperature at which solid changes to liquid, the temperature at which solid changes to gas, the temperature at which liquid changes to solid, or the temperature at which liquid changes to gas. Pause the video, think for an answer, and then check. If you answered the temperature at which liquid changes to gas, you are correct. Again, I'm repeating the same thing, that if you are not able to memorize all those things and you are getting confused between all the four change of state we will be doing in this lecture, you can pick one example of each and then you'll be able to remember which state has been changed to which state. Next state is condensation. Condensation is gas changes into liquid when the heat is removed or you give cooling temperature to it. Okay. For example, cloud formation. When a substance in the liquid state loses energy, usually by cooling, the particles move less. They're not able to overcome the forces of attraction and the particles slide past each other. In condensation, gas changes to liquid. This is gaseous state, this is liquid state, and when we take away the energy or cool it down, condensation occurs and it converts into liquid. After condensation, the substances will be in the liquid state. The individual particle remain the same size and shape. Also, make sure that you remember these particle diagrams so that you'll be able to see the changes, whatever we have read in the previous slides. That in this condensation, they said that the particles will slide past one another. When the particles start to slide past one another, they turn into liquid. And when they are completely packed or they can only vibrate in their position, that happens in solid state. When they're freely moving, then it is a gaseous state. So even if you remember the particle arrangement diagram, things will be very clear in your mind. Condensation point. The temperature at which substance changes from gaseous state to liquid state is called condensation point. Again, the thing to remember is condensation and condensation point are different things. Condensation is the process where the substance changes its states, whereas condensation point is the temperature at which this process or this change occurs. It is the same temperature as that of boiling point. So condensation point and boiling point are the same thing. For example, water boils at 100 degrees Celsius and condenses at 100 degrees Celsius. So both the temperatures will be the same. For example, on leaf on a summer day, you can see leaf having water droplets on it. Similarly, you can see little tiny droplets of water on windows or soda cans. On soda cans, you can see these dew formations when you take it out from the refrigerator and keep it in a room temperature. Question time. Select the correct option for condensation for each statement. Particles gain or lose energy and volume of substance decreases or increases. Pause the video, think of an answer, and then check whether you were right or wrong. If you answer that particles lose energy in condensation, you're correct. Volume of the substance decreases, then you are correct. How the volume decreases is you are going from gaseous state to liquid state. So when you go from gas to liquid, the volume changes because in here the particle arrangement is something like this. Whereas in gaseous, the particle arrangement is particles are really far away from each other. So volume expands in gases. Recalling boiling and condensation. Boiling is liquid changes into gas when the heat is added, whereas condensation is gas changes to liquid when heat is removed. This is liquid and this is arrangement of particle in gases. When we give energy to liquid, it boils and form gas. When we take energy from gas, condensation occurs and it turns into liquid. It is a reversible process. What's that state again? Let's see. Change of state, what was it? It occurs when matter changes from one state to another. Type of changes of state that we studied today was freezing, melting, boiling, and condensation. Okay, they both were reversible. They both were reversible. Check out YouTube Shorts or Instagram handle or TikTok handle for related practice questions.